Have you ever wondered why steel bends before breaking, but concrete suddenly cracks without warning? The answer lies in one powerful graph every structural engineer must understand: the stress-strain curve. In today's lesson, I'll explain how materials behave under load, what elastic and plastic behavior really mean, where failure starts, and why ductility can save lives. By the end of this video, you will clearly understand elastic versus plastic behavior, yield point ultimate strength, and the difference between brittle and ductile materials. Let's 6. The stress-strain curve is a graph that shows how a material reacts when we apply load. On the vertical axis, we have stress, force per unit area. On the horizontal axis, we have strain, deformation per unit length. This curve is obtained from a laboratory test, usually a tensile test. This single curve tells us how strong, how stiff, and how safe a material is. Let's begin with the first region, the elastic region. Here, stress is directly proportional to strain. This means if we remove the load, the material returns to its original shape, no permanent damage. Think of a rubber band. Stretch it slightly, release it, it comes back. Structures are designed to work mainly in this region. Elastic behavior equals safe and reversible. At a certain stress level, something critical happens, the yield point. This is where elastic behavior ends and plastic behavior begins. After the yield point, the material will not return to its original shape. Permanent deformation occurs even if the load is removed. In structural design, we carefully limit stresses to stay below the yield point, especially for steel structures. Beyond the yield point, the material enters the plastic region. In this zone, deformation increases rapidly. The material stretches without much increase in stress. This is a warning stage. Plastic behavior gives us visible signs before failure, like bending, cracking, or elongation. The highest point on the curve is called the ultimate strength. This is the maximum stress the material can carry. After this point, the material starts to next stress decreases, and finally, fracture occurs. Ultimate strength is important, but yield strength is more important for design. Ductile materials, like structural steel, have a clear yield point. Show large plastic deformation, give warning before failure. This is why steel is excellent for earthquake-resistant structures. Brittle materials behave very differently. Almost no plastic deformation, sudden failure, no warning. Brittle failure is dangerous because it happens suddenly. As engineers, we design steel to yield before breaking. We reinforce concrete to improve ductility, and we always prefer controlled failure over sudden collapse. To summarize, elastic behavior is safe, yield point marks permanent deformation. Plastic behavior provides warning, ductile materials save lives. In the next lesson, we'll apply these concepts directly to steel and concrete structures. If this helped you, like the video, subscribe, and share it with a fellow engineering student. See you in the next lesson.